Hi everyone, thank you for joining me again. So in this video, I'm going to show you how to graph piecewise functions. Hopefully the idea will make sense to you at the end of the video. So let's get to it. So here is our first example. We want to graph this function f of x. F of x is equal to x squared plus 1 on the interval when x is less than -1, and f of x is x minus 3 on the interval when x is greater than or equal to -1. So there are multiple ways you can graph piecewise function. We're going to do it by making a table of values. So here's what we're going to graph. We're going to graph the function f of x is equal to x squared plus 1 on the interval only when x is less than -1. That means you can plug in every x value as long as x is less than -1. So we can make a table of values for x and for f of x, and then we'll plot those points. So we'll pick -1, -2, and let's say one more, -3, because those are the values that are less than -1. Plug them into the function, so we have -1 squared plus 1, that's 2, and then we have -2 squared plus 1, that will be 4 plus 1, that's 5, and the -3 squared plus 1, that will be 10. So let's plug them. So now we make our xy plane. So here's our xy plane, and we're splitting up the plane into two separate regions when x is like -1. So here is -1, and we're only focusing on when x is less than -1. So we had -2, -3, -4, and so on. So the graph will only exist on the left side of -1. So when we plug in -1, we got 2. So -1, let's say this is 2. So that's right here. Now you have to be careful because x is strictly less than -1. This point, -1 comma 2, is going to be an open circle. So we plug this point, -1, to, but we put it open because that's the end point where the function is not defined. And we plug the next point, -2, 5. So let's suppose 5 is here, and -2, 5, well, somewhere over here. And then the next point, -3, 10, and of course that'll probably be somewhere further up here. So let's just say it's up there, -3, 5. And you connect them by making a parabola because x squared is a parabolic function. So we connect them and make our curve. So it will look something like this. Okay. And the endpoint, -1, is open. So that's the left side of -1. Now what about the right side of -1? Well, we're going to have a different graph. We're going to have x squared. We're going to have f of x equals x minus 3. So again, we do the same thing. We make a table of values, and then we plot them and make our graph. So let's plug in. When f of x is equal to x minus 3, on the interval x is greater than or equal to -1. So again, you can make a table of values. So we pick -1, so greater than, that's going to be -1, 0, and let's say 1. These are just some points. You can pick any other value that are greater than -1. And then we'll have our function values for these x values. Plug in -1 into the function. We have -1 minus 3, -4, 0 minus 3. That would be -3, and then 1 minus 3, that's -2. And of course, you can plot more points, but these are good enough. Now be careful with this point because this is the end point, -1, -4. This point is going to be closed circle because the inequality is greater than or equal to, so we make sure we shade in that circle on the graph. Now let's go to our graph. So we're going to plot these points, -1, -4. So -1, -4, let's suppose it's right here. So then we have this point, and it's closed because it's greater than or equal to. Then we have next point is 0, -3. Suppose that's right here. And the next point we had was -1, -2. 1, -2. So when x is 1, y is -2. That's right here. And we connect them because that's the graph on the right side, and it's a line because x minus 3 is a linear function. So we connect them by making a line. So there we have the graph when x is greater than -1. So the first piece represents f of x equals x squared plus 1, and the second piece represents f of x equals x minus 3. And that completes the graph for this function. Now let's take a look at another example. So you can do the same thing. You can make table of values, or you can just kind of use your intuition to come up with the graph. But first you must plug in the endpoint, meaning where the interval is going to split up. We're going to split up at 2 for this function. So let's go ahead and plug in. So we're going to do the top function first. We have h of x is equal to 2 minus 3x on the interval x is less than or equal to 2. And we're going to have the function h of x is equal to 1 on the interval x is greater than 2. So you should realize that this is a linear function. So it's a line, and this is just a horizontal line at 1. So using that knowledge, we can go ahead and graph these functions. So let me go ahead and draw my x and y axis. So here's our xy plane, and we're going to split up at x equals 2. So let's suppose 2 is here. So to the left of 2, we're going to have the function 2 minus 3x. So I'm going to go ahead and plug in 2. So when x equals 2, h of 2 is going to be 2 minus 3 times 2. And that will be 2 minus 6, which is -4. So the point -4, sorry, not -4, the point 2 comma -4, this is going to be a closed circle. The reason this is a closed circle is because of the inequality. It says less than or equal to, so we close in that circle. So plot 2, -4. So let's suppose 2, -4 is here. So that's right here, and we close because it's less than or equal to. And now just focus on to the left of 2, so you can plug in another point. Plug in 0, because 0 is less than 2. And then you find h of 0. So that would be 2 minus 3 times 0, which is 2. So we have the point 0, 2. So 0, 2 is going to be somewhere up here. So let's scale a little bit down so I can have a better picture. So that's 0, 2. And you see that to connect these points, we're going to make a line. So I'm going to go ahead and try to make a line to connect them. So, and then it just continues on that direction. So that's the graph of h of x, 2 minus 3x on the interval x is less than or equal to 2. Now when x is greater than 2, we have the function h of x is equal to 1. So again, let's suppose 1 is here. So then when x is 2, we have 2 comma 1. And this is an open circle because of this inequality. And then it's a horizontal line going to the right. So that will be the function h of x equals 1. So we have the first graph, which was h of x is equal to 2 minus 3x. And the second function we had h of x is equal to 1. So these are the different pieces for this given function. I hope this makes sense. Let's try another one to have a better understanding on this. Now for this example, we're graphing, again, two set of functions on two different intervals, But you have to also remember this graph only exists on this given interval, -2 and 3. So it doesn't exist on the entire real line, but it only exists from -2 to 3. So let's make a table of values. So first we're going to make table of values for f of x is equal to -x squared when x is strictly less than 0. So let's make table of values for this. So we have x, and then we have f of x. So we're going to plug in points that are less than 0, but we are going to plug in 0 to find where to start the graph. And we'll make sure to open that circle because it's strictly less than. Then we can plug in -1, -2. Now keep in mind, you cannot plug in any more points because of the interval. It only exists -2 to 3. So we'll have to stop at -2. So let's plug this into the function. We have f of 0, that would be 0. F of -1, that's -1 squared, which is -1. And then f of -2, that would be -2 squared, it's -4. So these are the function values we get when we plug in 0, -1, and -2, because that's the only interval we can actually have on this function. So let's go ahead and plot them first. So here is our xy plane. And let's just draw vertical line just to make sure we don't exceed those points. We have -2, 1, 2, 3. So I'm doing these vertical lines, dotted lines, so that we don't exceed these two x values for this given function, because we want f of x to only exist between -2 and 3. And then in between, we'll figure out the graph. So we're focusing on 0. When x is less than 0, we have -x squared. So when we plug in 0, we get 0. And this point, 0, 0, is open circle because it's strictly less than 0. So 0, 0 is right here. It's open. So I should use different color for that so it stands out. So here is 0, 0. And then we plug the -1 into our function. We get -1. So -1 is right here. So that's this point. And then -2, we got -4. Let's say that's this point right here. And that's right here. And we can't exceed anymore because the interval has to end at -2. And we connect them by making a parabola because x squared is a parabola. So keep in mind that this one, I didn't draw an arrow on the bottom. I'm not doing it like this because the graph has to end at -2. That's what's given in the question. So we'll just close the circle in. So that's the graph of this piece. Now for the other half, from 0 to 3, we're going to again make a table of values. So let's plug in 0, 1, 2, and 3, and then we figure out those function values. So we have the function f of x is equal to x squared plus 1 when x is greater than 0. Again, strictly greater than 0. So we plug in x values, then we get our function values. Plug in 0, 1, and I'm just going to plug in 3, and I'm skipping 2. But if you want to, you can plug in 2 as well, so you'll have more points. But let's just work with these 3. Now again, keep in mind you cannot exceed 3 because the function wouldn't exist beyond 3 on this given question. So we have f of 0, that's 0 squared plus 1, that's 1. And this point is going to be open, 0, 1, again because of the inequality given to us. And then the rest we're going to close them. So f of 1 is going to be 1 squared plus 1, that would be 2. And then f of 3 is going to be 3 squared plus 1, that's 4. No, 3 squared plus 1, that's 9 plus 1, that's 10. Right, almost doing my calculation wrong. Oops, sorry. Okay, so now we're ready to plot them. So I'm going to plot these points and then connect them by again making another parabola because x squared plus 1 is another parabolic shape. So we plug 0, 1. So 0, 1, suppose it's right here. Again, this is going to be open. and then 1, 2, 1, 2, that's right here. And then we have the last point. So I didn't plot 2, but let's do 3. That gave us 10. So 10 is all the way up there. So just extending this a little bit more, let's just say it's somewhere up here. And then again, I'm going to connect them by making a parabola. Okay, so that's that half of the graph. So you can see that completes our piecewise graph. We have this half, which is f of x is equal to negative x squared. And then when x is greater than 0, we have f of x is equal to x squared plus 1. And keep in mind this entire function, f of x, this is our f of x, which only exists from x equals negative 2 to x equals 3. So beyond that interval, this graph doesn't exist. Okay, so that's it. I hope these examples help you to understand piecewise functions.